All right, guys, we're going to jump into these points, lines, and planes notes. So, first things first, in geometry, we have these things called undefined terms. They are terms that cannot be defined. This is kind of like the foundation of geometry, geometric shape, and such. So, although they cannot be defined, they can be described, and there are three of them. They are points, lines, and planes. All right, so I'm going to get started with point. So a point takes up no space, but represents a location in space. Okay, so that's not a definition, that's just kind of describing what it is. So I know that you've been used to seeing a point as a dot. It's not literally a dot, though. A dot is used to represent it. And it's also named using a capital letter. All right, so for example, this guy right here, it's just W, or point W. Okay? Or you can just, like I said, call it W. All right, next is a line. A line is a straight path that extends in two opposite directions without ending. So basically it goes on forever and ever. And has no thickness, width, or length. A line contains infinitely many points. So if a point doesn't occupy any space, then neither can a line if it's made up of infinitely many points. All right, so through any 2 points, through any 2 points, there's exactly one line. So again, through any 2 points, there's exactly one line that you can draw through it. All right, naming a line. You can name any line by 2 points on that line. Order doesn't matter. That's very important. Order does not matter. Okay. Or you can use a lowercase letter. Okay, so I'm going to give you several examples for how to name this line right here. So we could call it line AB, and you simply put a line with like arrows on either side. Or you can call it line AC, or you can call it line BC. And you could also flip the letters, so you could call it line BA, you could call it line CA, or you could call it line CB. Any of those would be appropriate, or you could call it line N. So again, any of those are appropriate. For a plane is a flat surface that extends without end in all directions. It has no thickness, width, or depth. So a plane is usually symbolized by like a parallelogram looking thing. So it goes in all directions. And it goes through any 3 points that are non-collinear. And we'll talk about that in a bit. But non-collinear means points that do not make a straight line. All right. Naming a plane, you can use at least 3 points, or you can, that do not make a straight line. Right? Because don't forget they have to be non-collinear. Or you can use a capital cursive letter. So I'm just going to give you like 1 or 2 examples down here for the name. You could call this plane TSQ, or you could call it like plane P, something like that would work. Or you can literally write the word plane. That's my best job at a cursive P. All right, moving on. Intersection. So intersect just means where 2 lines or anything crosses, really. So 2 lines intersect at a point. And you can see that right there. 2 planes intersect at a line. Okay, which you can obviously see right there. So think about like when you're sitting in a room. I don't know if you've ever gotten bored and kind of looked at where the walls intersect each other. but if you ever take a chance to look, you'll notice that they intersect at a line. So that's kind of what two planes do. That's exactly what two planes do. A line and a plane, however, intersect at a point. So it's like if you had a sheet of paper and you poked a pencil through it, it would go through at a point. Okay, now let's talk about some defined terms. Defined terms are going to use, these are going to use undefined terms to help define them. So defined terms are terms that have a, definition. Okay, and a segment, this is going to be our first defined term. A segment is a part of a line, right? Because a segment just means a part of a line that has two endpoints. Okay, so you got an endpoint, you got a segment, and you got another endpoint. All right, so now naming a segment. So to name a segment, you just use its two endpoints. It's really simple. Pick whichever order. So you could name it AB and just put a line segment over it, or you could name it BA. And again, put a segment over it, no arrows, because it doesn't go on forever in either direction. All right, now we have array. It's also a part of line and it has one endpoint. And it extends indefinitely in one direction. Naming array. So arrays are named by stating the endpoint. Okay, so to name array, you simply use the endpoint and one of the other letters, one of the other points. So I'm going to start with C, and then I'm going to pick one of the other points, so A. Cool? And since this goes in that direction, that's why we know C has to go first. And just put an arrow pointing to the right on top of it. It always needs to face the right when you're naming it, or you could call it CB. No, you may not change the order. Order is important. It says it right here. Order is important. All right, opposite rays. If you choose a point, okay, on a line, then you can create two rays on that line. So once you do that, you'll see that it makes two opposite rays, and opposite rays make 180 degrees. Let me just kind of illustrate that for you. So if I have one ray that extends in this direction, try that one more time. There we go. And then if I have another ray that extends in the other direction, yeah. You know what? You're trying to play me right now. I appreciate it. There we go. All right, and they create a 180 degree angle. That's a straight line. 180 degrees is a straight line. All right, so naming opposite rays, you're just going to use their common endpoint. So I'm just going to pick this, and that's going to be how both of them start. So that's going to be B, and if you go in this direction, it's C. And if you go in the other direction, that's A. All right, so it's BC and BA. All right. Collinear. Collinear just means they're on the same line. All right, so points that are on the same line are collinear. That's why it's called collinear. Okay, and if we look over here at the diagram, you can see this line right here, and all four of the points that are on that line are considered collinear. So you could say, oh, A and B are collinear. A, B, and C, A, B, C, D, all of them are collinear. All right, now for non-collinear, that would be sets of points that do not lie on the same line. So if we use that same example, you could be like, oh, A, B, and E are non-collinear. All right, so again, A, B, and E are non-collinear. They're not on the same line. All right, coplanar. A set of lines or points, I'll put points first, points or lines that lie on the same plane. Any set of 2 or 3 points are coplanar. set of points or lines. I'm sorry, let me get to that in just a second. So basically, we're just saying that if you look at the diagram over here, if you pick any 3 points, I don't even care if they don't look coplanar. So like E, A, and C. Any 3 points you pick are coplanar. E, A, C, and you can connect them and they will make a plane. Okay, so I'm going to use those. A, E, and C are coplanar. Okay, didn't need to make a comma. Okay, all right, so now for non-coplanar, it would be a set of points that do not lie on the same plane. So if I look back over at the diagram, if I use A, E, and C again, and then I pick point B, that B is not on the same plane as the others. So we have A, E, C, and B. They are not coplanar, or they are non-coplanar. Okay? All right, so real quick before I continue, 2 points. I'll use a different color to emphasize what I'm saying. Okay, 2 points always automatically make a line. Okay, and 3 points always automatically make a plane or are coplanar. Okay, very important. All right, moving on. Skew lines. So you've heard of parallel lines. Skew lines are 2 non-parallel lines that do not intersect. So I know you've heard that parallel lines are lines that don't intersect. Well, there's also skew lines in a 3-dimensional setting. All right, so we have line AB that goes in, each direction infinitely. And then we have FG. Now, both of these lines are infinite, but they will never touch. If you notice, FG is like behind a bit, and it would keep going, and it would be like under AB. It would keep going under AB. They never intersect. All right, now parallel lines are 2 non-skew lines that do not intersect. So if you look over here, we can see AB, CD, GH, and EF. Those are all parallel. So just pick 2 if you like. So line AB and line CD. These are parallel. And this is the symbol for parallel. Get to know this symbol really well because I use it a lot, especially because this is geometry. So I'm going to go ahead and use it right here. Those are parallel to each other. All right, last but not least, a contained line, a line that lies completely on a plane. All right, so let's look at the examples. Excuse me, we have this line. It's completely on this plane. No part of it is off this plane, right? So we would say like line AB is contained. Down here, we have this situation, and then we have this line that's going through the plane. So I would say line VP, I'm just using 2 points to name this line, is not contained. And let me be specific, in plane R. And I'll do the same thing for this one, in plane N. And that's pretty much it. That's what you need to know. And yeah, see you later.